At Kimbriki Resource Recovery Centre, we've spent 5 years of hard work going from no gas management to best practice. So today I'll tell the story of a small landfill that took some big ideas to address landfill gas emissions and made them work in a cost-effective way. We took the typical landfill gas extraction system and made it better. We took the residue from the recycling of garden waste and put it to good use. We conducted a landfill gas risk assessment and started implementing the measures before the new landfill guidelines were released. The Kimbriki Resource Recovery Centre is at Ingleside, in the hinterland above Sydney's beautiful northern beaches. The total area of the site is 64 hectares, with about 40 actively in use. Before 2009, it was operated by several councils in a joint services committee, who then set up Kimbriki to manage the site. The centre has a landfill and small vehicle transfer station for non-putrescible waste, resource recovery facilities for building and demolition waste and garden waste, aggregation facility for mixed recyclables, drop-off points for e-waste, batteries, motor oils and charity bins, buyback shop and the Eco House and Garden Education Centre. So as you can see here, we've got plenty of activities happening beside each other, and we get really busy with a lot of workers and visitors around the site every day. In 2016, over 330,000 tonnes of waste was received, and 55,000 tonnes of that was landfilled. So 80% of our incoming waste is recovered and then diverted from landfill. Since 1974, about 3.5 million tonnes of waste has been landfilled, and in the next 30-odd years, we're landfilling another 2 million tonnes. So that's a lot of gas to capture. We don't take food waste, and the lower organics content means that we've got a lower gas generation potential. However, we have been injecting leachate into the waste mass, which speeds up the rate of generation. When the company was established, there was no management of landfill gas, besides compaction and covering of the waste. But this didn't control fugitive emissions through the cover material, and in particular, emissions through batter slopes, where the cover material is less compacted. By the way, that is not a photo of the Kimbriki site. It's actually a barge carrying waste across the water at the spit before the bridge was built. When the carbon pollution reduction scheme was proposed, we assessed the centre's landfill gas generation and emissions using models from the International Panel on Climate Change. The models showed very high levels of emissions across the landfill surface. We then commissioned Fluxbox tests to validate these models with actual site data. The test showed very low emissions though, so we didn't take further actions to manage landfill gas. However, we did find problems with the test methodology later on, and besides, trying to directly measure emissions is very challenging. We reviewed the site's landfill gas generation, emissions and management options as part of our preparation for our site master plan document and the impending implementation of the carbon pricing mechanism. We found that we would have a large financial liability with the carbon tax, and the financial risk was the driving force for us to look at options such as undertaking a risk assessment, installing an active gas extraction and flaring system, investigating reuse of landfill gas, and evaluating opportunities for generating carbon credits. So the first item on our list was the installation of an active gas extraction and flaring system of vertical wells and a flare. The wells were installed in waste under intermediate cover, and we went from capturing no gas to 120 cubic metres of gas per hour almost straight away. It's no surprise that the system led to a big reduction in odour nuisance. So the flaring system looks like this, with the wells in red interconnected by the underground pipes in green. Deciding where to put the wells wasn't as simple as pin the tail on the donkey, because first of all, there is no donkey on this map. But we do have 2 goats that roam around the site. Secondly, we just have so many people and activities to work around. I mean, we've got to work around our, what's the point? We've got to work around our construction and demolition waste contractors. We have to work around our garden waste contractors. We have to cause the least disruption to our landfilling operations. We have to avoid digging up busy roads and cause the least disruption to customers driving in to drop off mixed recyclables, mixed waste, mattresses, metals and tyres in this area. We had to think ahead to how the area may change to protect the wells. For example, if stockpile material will be placed over here. We also need to put the wells where there's safe and easy access for inspections. Now, despite the carbon tax ending in 2014, we expanded the flaring system because we were pulling so much gas and we wanted to do better. So what we did is we modified the typical vertical well flaring system by experimenting, refining and perfecting the installation of horizontal collection trenches. Here is a typical installation. 30 to 40% of our landfill gas flow is captured in these innovative systems. There were 4 main drivers behind the development of the horizontal collection trenches. The first driver is actually a driver. So imagine if you were that person in the landfill cell, weaving around those vertical wells. We could install the vertical wells and extend them upwards as the waste gets higher and hope that nobody runs them over, or we could wait for the cell to reach final landform and then install the wells. We thought it was more practical to actually install horizontals in the waste because they're protected from the compactors and trucks, making life much easier for the drivers. You don't have to worry about dodging obstacles. We'll still install vertical wells at final landform. However, we won't need to install as many because we're already capturing gas with horizontals in a few layers of the waste. The second driver was the time it would take to fill the cell to final landform. Cell 3A, which is here, was going to take 2.5 years to fill to final landform. And if we wait to install vertical wells, which is normal practice, loads of gas would go uncaptured and we'd be dealing with the potential for odour nuisance again. Also, the smaller footprint at the top of the landfill cell would reduce the number of vertical wells installed anyway. And if we had waited for cell 3B to fill up against cell 3A, we could be waiting 5 years to install wells in both cells. So when we began operating the centre back in 2009, we inherited a problematic landfill shape. The centre of the valley was filled to a high mound and the edges tapered down to the ground with steep batter slopes. And because of their steepness, we had to fill in such a way that our most recent landfill cells interface with these old batter slopes. Now these interfaces became hotspots for fugitive emissions which traditional vertical wells cannot capture. By installing horizontals within a few metres of these interfaces, we can stop these emissions. The fourth driver for progressively installing horizontals was the cost. In total, it cost us $115 per metre length of trench for horizontals and about $1,300 per metre depth of well for verticals. So the installation of horizontals may seem simple, but there are some traps and we found them the hard way. So as gas is being collected through these pipes, condensate can build up, blocking gas flow. So we found we had to allow for settlement in the design process. We've got to ensure that the pipes are installed at a steep enough gradient so that condensate can drain from the pipe as it settles with the waste. And we found that a minimum 3% grade works. We also had to think about the spacing of perforations. There could be areas along the pipe where there's more settlement, causing a little dip in the pipe. There needs to be a perforation in that dip so that condensate can drain from it. And we found that 10mm diameter perforations at about half-metre spacings works. We're now collecting 60% of the gas generation modelled for the site. The horizontals in the deeper layers of waste collect about 80 cubic metres of gas per hour, and the 2 best performing vertical wells collect about 100 cubic metres of gas per hour. We're flaring more and more gas each year, and this year we're actually forecast to collect 20% more than we did last year. We will continue to expand these collection system over the operational life of the landfill. All of this innovation isn't cheap, and without power generation, there is no income apart from the earth scheme. So what we did is we registered the flaring system as an emissions reduction fund project. We were awarded a carbon abatement contract, and it was agreed that we would deliver 79,000 tonnes of carbon between 2016 and 2023. So that's an annual average of 11,000 tonnes of carbon. Actually, in our first carbon offset report, we've put in a claim for about 16,000 tonnes of carbon. So we're generating excess carbon credits, which we could sell in the future. And this is going to significantly reduce the cost of operating and expanding the system. We used to rely on consultants to do surface emission scanning in small areas of landfill, but this was expensive and time-consuming. So what we did is we decided to bring that in-house by hiring rental equipment. However, we couldn't immediately investigate odour nuisance because we'd have to wait 2 to 3 weeks for the higher methane detectors. We then bought our own methane detector, and that enabled us to do ad hoc scanning across small areas of the landfill where not as much gas is being captured by the active gas extraction system. By developing this resource in-house, we can quickly respond to odour nuisance, find out what's causing the fugitive emissions, and then improve our landfilling operations. We spent $26,000 on this methane detector, but it's worth the investment because we're using it a lot and we're saving time and saving money. The only downside is that someone's got to wander around landfill looking very unfashionable with this device strapped to them, and that person is often myself. Another innovation to manage landfill gas was biocovers on landfill embankments. So in consultation with the New South Wales EPA, we experimented with a mixture of recycled garden organics to see their impact on methane emissions. There was no guidance on how to construct these, by the way. Now, because the trial was successful, the New South Wales EPA issued us a licence variation for the extended application of biocovers. By the way, that's me, not a mountain goat hiking up the mountain. So by the end of the trial, average methane concentrations across the embankment had fallen by 96%. Now, despite the trial showing the effectiveness of biocovers to reduce landfill gas emissions and to control erosion, it wasn't cheap to bring this material into landfill because they incur the waste levy. So far, we've paid $200,000 for these biocover material, so we're currently working with the EPA to exempt them from the levy and therefore make them more cost effective. In a move towards best practice, we decided to begin a landfill gas risk assessment before the new New South Wales landfill guidelines were released. Over 170 on-site and off-site receptors were covered, and these activities are always changing around the site, so we're going to have to regularly review and update the risk assessment. As you can see here, we have plenty of activities happening around the site and therefore many receptors to assess. So we divided the receptors into on-site, on-waste, then adjacent to waste, and then off-site receptors. We assessed many details about these receptors, for example, the availability of ventilation at the receptor, whether there were any underground services, and the proximity to the gas extraction wells. We needed to know more information about these off-site receptors, and so we visited each one for inspection, and we now conduct periodic scanning of high-risk areas. So key lessons and challenges. We learnt that to make all of this possible, it's important to have good planning. And this means involving key stakeholders in open discussions to have a thorough evaluation of existing gas management practices. It's important to have highly experienced people on the team who have expert knowledge. And if there's a knowledge gap, then choose the right contractors who are willing to work collaboratively. By developing the gas emission scanning monitoring resource in-house, we've got a greater sense of our gas management, and we're also saving time and money. It's also important to do the gas risk assessment in-house because it needs to be regularly reviewed and updated by someone who has a good understanding of how the site operates. Looking ahead, we will expand the gas collection system into our active landfill cell 3B. With the high gas flows in the gas collection system, we're looking at ways to utilise the captured energy to use the captured gas as an energy source, such as powering a leachate treatment plant and other energy-intensive uses on site. And pending the resolution of the waste levy issue for biocovers, we would really like to expand the application of biocovers to other areas of the site. So when it comes to managing landfill gas, Kimbriki has come a long way from where it was 5 years ago, but we're committed to continue improving our gas management practices. Thank you.